continuous probability. Ito naman yung parang counterpart niya, which is yung uh, joint probability distribution. So, yung last time na-discuss natin yung mga posons, no? Bago tayo mag-midterm yan. So, ano yung mga topic naman na madidiscuss natin ngayon? Yung group na mga kayo makali. Pang ano na kayo, di ba? Pangatlo, no?
Opo, group 3 po.
Ayan. So, yung mga random variables, ayan. Linear function, general function. So, sana ma-discuss natin lahat. Yan, once ready na kayo, pwede na kayo mag-start para yan, maximize natin yung oras.
Yes, sir. We can start na po. Good
Sige, go
afternoon.
ahead.
Yan. Good afternoon, everyone. This is Group 3, and we will be reporting on the topic of joint probability distribution. And these are the learning objectives. First, compute the joint probability distribution of random variable for both discrete and continuous data. Second, know the linear general functions of random variables. Third, to learn the formal definition of a joint probability distribution and its function. We will be tackle the topic of joint probability distribution and includes two or random variables, joint probability distribution, marginal probability distribution, conditional probability distribution, more than two random variables, linear functions of random variables, and general functions of random variables. We can start on the topic of two or random variables.
My name is Marjan Bensurto, and I will discuss the two or random variables. Random variables is a variable whose values is unknown or a function that assign value to each of an experiment outcomes. Random variables are often designated by letter and can be classified as discrete, which are variables that have specific values, or continuous, which are variables that can have any value within a continuous range. So meron yung ating random variables ay merong two part, which is yun ang discrete and continuous. Types of random variables. Random variables are classified into discrete and continuous variables. The main difference between the two categories is the type of possible values that each variable can take. In addition, the type of random variables implies the particular method of finding a probability distribution function. First, discrete. Discrete random variables is a random variables whose values take only a finite number of values. The best example of a discrete variable is a dice. Throwing a dice is a purely the random event. At the same time, the dice can take only a finite number of outcomes like 1, 2, 3, 4, 5, and 6. Each outcome of a discrete random variables contain a certain probability. For example, the probability of each dice outcome is 1 over 6 because of outcomes are of equal probabilities. Note that the total probability outcome of a discrete variable is equal to 1. Second, the continuous. Unlike discrete variables, continuous random variables can take on an infinite number of possible values. One of the example of a continuous variable is the return of stocks. The return can take an infinite number of possible values as percentage. Due to the above reason, the probability of a certain outcome for the continuous random variables is zero. However, this is always a non-negative probability that a certain outcome will lie within the interval between the two values. Key takeaway. A random variables whose values is unknown or a function that assign values to each of an experiment outcomes. A random variables can be either discrete, having specific value, or continuous, any value in a continuous range. Then the use of random variables is most common in probability and statistics, where they are used to quantify outcomes of random occurrences. Next, risk analysts use random variables to estimate the probability of an adverse event
Relax
occurring.
lang, huwag mo masyadong madali yung pagbabasa, nabubulol ka.
Sorry, sir.
Sige, continue.
Example of random variables. A typical example of a random variables is the outcome of a coin toss. Consider a probability distribution is which the outcome of a random event are not equally likely to happen. If the random variables y is the number of head we get from tossing two coins, then y could be 0 or 1 or 2. This means that we could have no heads, one head or both heads on a two coin toss. However, the two coins land in four different ways: tails, 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 head, and head. Therefore, the probability of y is equal to 0 and equal to 1 over 4, since we have one chance of getting no head. Two tails when the coins are tossed. Similarly, the probability of getting two heads is also 1 over 4. Notice that getting one head has a likelihood of occurring twice in head tails and tails head. In this case, probability of y is equal to 1 and equal to 2 over 4 and 1 over 2. So, yan po yung example ng toys ko na na merong apat na ay maraming possible outcomes po.
Sige, di-discuss ba yan? Yung magdi-discuss.
Matthew.
Oh, good afternoon po, sir. So I'm Matthew Gading, and I'm a reporter in this topic. So this is the examples of discrete random variables. First, the following are examples of discrete random variables. First, the number of cars sold by a car dealer in 1 month. Second, the number of students who were protesting the tuition increase last semester. Third, the number of applicants who have applied for a vacant position at a company. And last, the number of typographical errors in a rough draft or of a book. For each of these, if the variable is x, then x is equal to 0, 1, 2, 3, and infinite. Note that x can become very large. In statistics, when we are talking about the random variable itself, we write the variable in uppercase. And when we are talking about the values for random variable, we write the variable in lowercase. Next. Wait. Next is the examples of continuous random variables. First, the length of time it takes a truck driver to go from New York City to Miami. Second, the depth of drilling to find oil. Third, the weight of a truck in a truck weighing station. And last, the amount of water in a 12-ounce bottle. For each of these, if the variable is x, then x is less greater than 0 and less than some maximum value possible. But it can take on any value within this range. Next examples. For the following situations, determine whether a discrete or continuous random variable is involved. So example number 1, the number of hairs on a sea otter. In this example, this is a discrete random variable because the hairs are something we can count. Even though the number of hairs may be very large, then we wouldn't actually want to count them. There are no half hairs or fractional amounts of hair, only whole number amounts of hairs. Second is the length of a sea otter. So this example is a continuous random variable because the sea otter will typically not measure exactly 5 feet, but the length will differ by some fraction of a foot. Next, this example number 3, the age of a sea otter. In this example, can be discrete or continuous random variable because we generally report age as only a number of years, but sometimes we talk about sea otter being 3.5 years old. Technically, since age can be treated as a continuous random variable, then that is what is considered unless we have reason to treat it as a discrete variable.
My name is Angelo Vilacruz. I'm here to discuss joint probability distribution. Joint
Ano nga
distribution
ulit
is
ang name? Medyo kinakain mo sinasabi. Ang hello.
joint probability distribution. Joint distribution is based on joint probability, which can be simply defined as probability of two events variables happening together. These two events are usually called event A and event B, and can formally written as probability of A and B intersect is equals probability of A times probability of B. Excuse me. Where probability of A and B intersect is the notation for the joint probability of event A and B. Probability of A is the probability of event A occurring, and probability of B is the probability of event B occurring. Next, please. Notation to represent the joint probability can take a few different forms. The following formula represent the joint probability of event with intersection. Probability of A and B intersect where A and B is equals to event, and probability of A and B, comma, probability of A and B is equals to the joint probability of A and B. The symbols in a joint probability is called an intersection. The probability of event A and event B happening is the same thing as the point where A and B intersect. Hence, the joint probability is called the intersection of two or more events. We can represent this relation using the Venn diagram as shown below. Um, joint probability, yung, excuse me, probability of A and B intersect, ito po yung formula niya. Um, Example po, let A and B be the events of getting a 2 and getting in a 3 when a die is sold. Then, probability of A is equals 1 over 6 and probability of B is equals 6, 1 over 6. In that case, A and B are mutually exclusive as we cannot get 2 and 3 in the same roll of die. Hence, the probability of A intersect B is equal to 0. Next, please. Joint probability table. A joint probability distribution represents a probability distribution for two or more random variables instead of events being labeled A and B. The condition is to use X and Y as a given below. F of X and Y is equals probability of X equals X and Y is equals Y. The main purpose of this is to look for relationship between two variables.
Good afternoon, sir. Good afternoon, everyone. I am Billy Joe Embaledo from Group 3. Joint distribution or joint probability distribution shows the probability distribution for two or more random variables.
Medyo may echo yata, Billy. Sa'yo ba yun?
Yes, f of x, y equals probability x equals x, comma y equals y. The reason we use joint distribution is to look for a relationship between two of our random variables. Here, we look at two coins that both have roughly a 50-50 chance of landing either heads X or tails Y. Let's take a look at this table. As you can see, we use a table to identify. Hello? Hello?
Sige lang.
Rinig ako, sir?
Yep.
Hello?
Oo, naririnig ka nga.
Sorry, sir. Ulit. Let's take a look at this table. As you can see, we used a table to identify easily the probability of getting either head or tail when we toss a coin toss. Two coins. Here the probability of getting double X is 25% and XY is 25%. Same as YX is 25%. Rinig ba ako? And double Y is 25%, which X means head and Y means tail.
So meaning, kapag meron ka daw dalawang coin, no, tapos pinagsabay, so you have 1/4 no chance of getting both heads or heads and tail or both tails or tails and head. So 25% or 1/4 lang.
Yes, sir.
Sige, continue.
Visual presentation. A joint probability can be visually represented through a Venn diagram. Consider the joint probability of rolling two sixes in a first six-sided dice. Shown on the Venn diagram above, the joint probability is where both circles overlap each other. It is called the intersection of two events.
So ito yung example, yan ba yung example kanina? Yan pa rin yan. Let us see some examples how to find the joint probability with solution. Find the probability. Kanina yan. That the number 3 will occur twice when two dice are rolled at the same time. Makali.
Kay Angelo po.
Ang hello.
De La Cruz.
Oh, nasa na si De La Cruz?
Pwede po.
Sige. So yan example ng Venn diagram kanina ni Billy Joe.
Yes po. Ito po yung example. Kumbaga, ito lang po yung pinaka-solution kung paano po yung process ng pag-compute po nun.
So yung Venn diagram kanina, makikita nyo may left side, may right side. So probability ng A yung left side, probability ng B yung right side. Then yung intersection, syempre yun yung pinaka-joint or yung pinaka-intersection nila. So yun yung pinakasagot. So to get daw the probability to get 3 that will occur twice, no, in a 2 die, no. So you need to get the probability of the first die. So para makakuha daw ng 3 sa 6 spaces nung die, di ba? Isa lang naman yung probability, kaya naging 1/6. So ganun din yung sa pangalawang die, which is yung probability B. Then gamit yung product, no, or intersection. So multiply lang daw yung probability A and probability B. So 1/6 over times 1/6, that will be 1/36. So, yan yung pinaka-probability. So, next. O, ikaw na ang hello, wag kang pumalakpak dyan. Ikaw na mag-discuss.
Ano, sa next, Thurs.
Ito pa lang ang hello.
Kaya ko ba ulit? Here are the example of joint probability. Example 1, let us see some example of how to find the joint probability with solutions. Find the probability that the number 3 will occur twice when two dice are rolled at the same time. Ito po yung solution yung tulad nga yung sinabi ni Sir. Sorry. Number of possible outcomes when a die is rolled is equal 6. That is 1, 2, 3, 4, 5, and 6. Let A and B event of occurring 3 the first die and B the event of occurring 3 on the second die. Both the dice have 6 possible outcomes. The probability of 3 occurring on each die is 1 over 6. The probability of A is equals 1 over 6. And probability of B is equals 1 over 6. Probability of A and B is equals 1 over 6 times 1 over 6 is equals 1 over 36. Next, please.
Hello, sir. Rinig ako.
Oo, huwag ka sumigaw.
Thank you, sir.
Name, Billy Joe pa rin.
Example 3. What is the joint probability of getting a head followed by a tail in a coin toss? Event A. The probability of getting a head in the first coin toss is 1 over 2 equals 0.5. Event B. The probability of getting a tail in the second coin toss is 1 over 2 equals 0.5. Therefore, the joint probability of event A and B is probability 1 over 2 times probability 1 over 2 equals 0.25 equals 25%. Example 4. Example 4.
Dahil lang Billy Joe. So, yan yung mga example ng mga common joint probability distribution. No?
Yes,
So,
sir.
Anday lang.
Ito yung
Yan lang naman yung mga example. Dice, coin, sa cards. So, yan yung mga common trees. Common topic sa mga joint probability. So pinaka-concept is usually sa joint probability, you have two events lang naman. So, una, kunin nyo lang yung probability ng first event. Then, pangalawa, kunin nyo lang yung probability ng second event. Then, combine. Then, that will be the joint probability. So, kung ibahin man yung question or ibahin man yung scenario, hindi na sa die, hindi na sa coin or sa cards. So, ang gagawin nyo lang, syempre, kukunin nyo lang yung unang pinaka sample size, then gather the probability kung ano man yung condition. Kunyari sa classroom may 50 students, so what will be the probability kung yung girl lang ang piliin? So parang ganun. So kahit man magbago, so mag-stick lang kayo dun sa process ng concept ni joint probability. Probability A, probability B, then times. So ito naman, yung next example ni Billy Joe is sa ano naman to, ayan, no? Drawing a number 10 cards that is black. So hindi kasama yung joker dito, di ba? 52 eh. 52, tama ba? So, sige, discuss mo na, Billy.
Thank you, sir. Example 4. Is the joint probability of drawing a number 10 card that is black. Event A, the probability of getting a 10 equals 4 over 52.
So bakit
equals
naging 4
0.
yung Billy? Ilan ba yung black na 10 sa cards? Ay, sorry. 10 lang pala, hindi pa kinonsider yung kulay. So that
Bale,
yung
sir, ito na yung solution.
so bakit naging 4 nga? Bakit naging 4? So meron kasing 10 yung spades, meron 10 yung clover, yung heart, may 10 yung diamond, ano pa yung isang block sa baraha? Spades, spades saka clover, isa lang, di ba? Diamond, heart, ano pa yung isa? Yung
Flower.
pang-apat,
Wait.
yan yung flower. So kaya naging 4. So drawing 10 pa lang, hindi pa kinonsider yung kulay. Then event B, probability of drawing a black cards. So syempre 52 cards, hati lang naman yon sa black and red, di ba? Yung heart saka diamond puro red. Yung clover saka yung isa spades is 26 din. So kaya naging 26. Then gather probability, sige. Billy Joe.
So, yan, sir.
Sige na,
Bale, sa,
discuss.
ano na.
Multiply na lang.
Po,
So
4
multiply
over
yan, over 4 over 52 times 26 over 52, that will be 0.038, or meaning that will be, pag percentage ang hinahanap, 3.9%.
yes, sir.
Sige, next Makali. IMB.
Hello po, sir.
Sige, magpakilala.
Yan Luis Garcia po, sir. Reporting marginal probability distribution.
Garcia. Garcia ba?
Apo,
John
Garcia po,
Garcia.
sir. Apo. Proceed na po ako, sir.
Go.
Marginal distribution is a distribution of values for one variable that ignores a more extensive set of related variables in dataset. How to find distribution? Marginal distribution. It's easiest to understand and find marginal distribution using two-way contingency table. In fact, that origin of the term originates from these tables. The table below originates that the data we collected for our computer type by gender study. Sa table na po ito, pinapakita po yung mga bilang ng male, female, PC, Mac. Tas pag inad po yung mga yan, yung 66 tsaka 40, nag-equal po sa 106. Tas ito rin po yung 30 plus 87, 117. Tas ito po, yung equal po nun pag pinlas, ano po, pa upside down po, 223. Tas yung isa din po, sir, ganun din po. 223 din po yung equal. Next na po. To find them, look at in the margins of contingency table, hence the name. I've circled the values in the margin that represent the dispersal of one variable without considering the other variable. There's a marginal distribution of for computer type and another for gender. Let's go back to understanding the dispersal of computer types while disregarding gender by looking at the margins in the table. We see that there have the following sales. Statisticians say you need to marginalize out the other variables to find a marginal distribution. In the example above, we marginalize out gender to reveal the dispersal of computer type. Next na po. We may be interested in the probability of an event for one random variable, irrespective the outcome of another random variable. For example, the probability of x equals to y I equals to a for all outcomes of y. The probability of one event in the presence of all or a subset of outcomes of the another random variable is called the marginal probability or the marginal distribution. The marginal probability of one random variable in the presence of additional random variable is referred to as the marginal probability distribution. Next na po. Nicola,
Hello po, sir. Ah, I'm Nicola Balanon, reporting po. Okay. It is called the marginal probability because if all outcomes and probabilities for the two variables were laid out together in a table, x as columns and y as rows, then the marginal probability of one variable x will be the sum of probabilities for the other variable y rows on the margin of the table. There is no special notation for the marginal probability. It is just sum or union over all the probabilities of all events for the second variable and for a given fixed event for the first variable. Probability of x equals a and equals to sum. Probability of x equals a and y equals yi for all y. This is another important foundational rule in probability referred to as the sum rule. The marginal probability is different from the conditional probability because it considers the union of all events for the second variable rather than the probability of a single event. Okay, next po. Okay, example question. Calculate the marginal distribution of pet preference among men and women. Okay. Step number 1, count the total number of people. In this case, the total is given in the right-hand column of 22 people. Step 2, count the number of people who prefer each pet type and then turn the ratio into the probability. So, people who prefer cats is 7 out of 22 is equals to 0.32. People who prefer fish, 7 over 22 equals to 0.32. People who prefer dogs, 8 over 22 is equals to 0.36. So, we can divide column totals into how many people voted. And as per result, you can add it and the answer is 1. Let's take a look into the table. Men voted for cats, 2. And fish, 4. Dogs, 6. And for women, they vote cat, 5. Fish, 3. Dogs, 2. After that, we turn the ratio into probability for for cat 2 plus 5 is equals to 7 and for fish 4 plus 3 is equals to 7. Dogs 6 plus 2 is equals to 8. So you can divide it all. You can add. So the answer is 22. We can check the probability by making sure it is all add up to 1. So 7 out of 22 is equals to point 32 and 7 over 22 is equals to point 32 and 8 over 22 is equals to point 36 and it is equals to 1. Okay. Thank you po. Next.
Hello po sir, my name is John Andre Diaz and di-discuss ko po ay conditional probability distribution. So what is conditional probability distribution? Conditional probability is defined as the likelihood of an event or outcome occurring based on the occurrence of a previous event or outcome. Conditional probability is calculated by multiplying the probability of the preceding event by the updated probability of the succeeding or conditional event. Key takeaways. Conditional probability refers to the chance that some outcome occurs given that another event has also occurred. It is often stated as the probability of B given A and is written as probability B given A, where the probability of B depends on that of A happening. Conditional probability can be contrasted with unconditional probability. Probabilities are classified as either conditional, marginal, or joint. Bayes' theorem is a mathematical formula used in calculating conditional probability. Next. Conditional probability formula. Ito po yung conditional probability formula. Probability B given A is equals to probability A and B over probability A, or probability B given A is equals to probability A intersect B over probability A. Next. Examples of conditional probability. As an example, suppose you are drawing three marbles, red, blue, and green, from a bag. Each marble has an equal chance of being drawn. What is the conditional probability of drawing the red marble after already drawing the blue one? First, the probability of drawing a blue marble is about 33% because it is one possible outcome out of three. Assuming this first event occurs, there will be two marbles remaining with each having 50% of chance being drawn. So the chance of drawing a blue marble after already drawing a red marble will be about 16.5% or 33% times 50. Next po. How do you calculate conditional probability? Conditional probability is calculated by multiplying the probability of the preceding event by the probability of the succeeding or conditional event. Conditional probability looks at the probability of one event happening based on the probability of a preceding event happening. Next po. The probability of one event given the occurrence of another event is called the conditional probability. The conditional probability of one-to-one or more random variables is referred to as the conditional probability distribution. For example, the conditional probability of event A given event B is written formally as, ito po yung kung paano po siya isulat, sir. This assumes that the probability of B is not zero, is not impossible. The notion of event A given B does not mean that event B has occurred. Instead, it is the probability of event A occurring after R in the presence of event B for the given trial. Next. Examples of conditional probability. As another example, suppose a student is applying for admission for a university and hopes to receive an academic scholarship. The scholarship to which they are applying accepts 100 over 1,000 applicants, which is 10%, and who are accepted 2%. Of the scholarship recipients, 50% of them also received university stipends for books, meals, and housing. For the students, the chance of them being accepted and then receiving a scholarship is 2%, 1 times 0.02. The chance of them being accepted, receiving the scholarship, then also receiving a stipend books, etc. is 0.1% or 0.1 times 0.02 times 0.5. Next break po.
Nawala.
Hello.
Ganun.
Rinig ba ako?
Tapos na po yun, sir, yung sa ano.
Okay. Sino na ba?
Hello?
State your name.
Hello?
Sige lang.
Ay, sir, rinig ako.
Okay, sige. Tuloy na. John Mark ano ka? John Mark apelyido.
Abad po.
Abad. Okay, sige. Medyo ano lang, parang nagpi-feedback yata.
Okay po, sir.
Ano ba gamit mo? Headset? Earphone?
Earphone. Yung isang.
Ha?
Saka po yung isa.
Nag-ano yung isa. Pero okay lang, medyo ano naman rinig. Huwag mo na masyadong galawin.
More than two random variables. Probability of multiples. Example, data of each row represent observation. Column represent variable may either discrete, meaning that they can take on a finite set of values, or continuous, meaning that they can take on a real or numerical value. Such we and you're interested.
Mahina, ano? Abad. Medyo mahina. Nag-feed. Loudspeak mo na lang. Naka-phone ka ba? Laptop.
Naka-phone po ako. Hindi po gumagana kasi yung sa mic ng phone ko. Kaya nag-earphone po ako kasi sira din yung earphone.
Yan, medyo okay na yan. Yung boses mo ngayon.
As such, we are interested in probability across two or more random variables. This is complicated as there are many ways that random variables can interact, which in turn impact their probabilities. This can be simplified by reducing the discussion to just two random variables, x and y, although the principle generalizes to multiple random variables. Next. And further to discuss the probability of just two events, one for each variable x equals to a, y equals to b. Although we could just easily be discussing groups of events for each variable, therefore we will introduce the probability of multiple random variables as the probability of event A and event B, which in shorthand is x equals to A and y equals to B. We assume that the two random variables are related or dependent in some way. As such, there are three main types of probability we might to consider. They are joint probability, probability event A, and event B. B pala. Marginal probability, probability event X equals to A given variable Y. Conditional probability, probability event A given event B.
Sir, good afternoon. Ay,
Sige, state your name, please.
ikaw po, rinig ba ako?
Dinig naman.
Good afternoon, sir. My name is Boris Labev, Spirit 2 of Group 3. And the example is definition 4.1.1. An n-dimension random vector is a function from a sample space into the set of real numbers. N-dimensional enclosed space. Suppose, for example, that with each point in a sample space, we associate an order pair of numbers that is a point x and y in an element of in a set of real numbers 2 where The set of real numbers 2 denotes the plane. Then we have defined a two-dimensional random vector x and y. Sample space for dice considered the experiment has 36 equal likely points. Let equals the sum of the two dice and equals wait, not there. And y equals the difference of two dice. In this way, we have defined that bivariate random vector x and y. The random vector x and y defined above is called a discrete random vector because it has only a countable number of possible values. The probabilities of event defined in terms of x and y are defined in terms of probabilities of the corresponding events in the sample space. For example, probability of x is equals to 5, y is equals to 3, equals probability for 1, 1, and 1, 4 is equals to 2, 36, and equals to 1 and 18.
Function, here denoted by that lowercase p of x and y. So it's a function of particular values x and y, and it tells you the probability that the random variable x is equal to the value little x, and that the random variable y is equal to the value little y. Typically, we don't write it using the intersection symbol, but instead we use the comma symbol. So anytime you see that comma symbol, you should be thinking about it as an intersection or the event and another event. All right, so that's the joint probability mass function for two discrete random variables. Here's an example that we'll use throughout the video today. So it's a very simple example. Imagine a box. The box only has 5 CPUs in it. There's 3 different speeds. So 2 of them are 400 megahertz. 1 of them is 450. 1 of them is 500. Sorry, 2 of them are 500. So those are the 5 different CPUs in this box. And all you're going to do is you're going to select 2 out of the box without replacement. That means you don't put the first one back in before you select the second one. And you're going to do this randomly. And we're going to define that x is the random variable that has the speed of the first one that you randomly pulled out. And then y will be the speed of the second one that you have randomly pulled out. So that's the example we're going to use throughout the day today. If you think about what the possible outcomes of this experiment are, you can just set up a table to describe them. So in this table, what we have is everywhere there's an x, that's something that's possible, and everywhere there's a dash, that's something that's impossible. Right? And here, in order to enumerate all the different outcomes, we have assigned numbers to each of the different CPU chips with their speed. So you can see that the first column, the first row, has a 400, but then a subscript 1. So that means that we've identified one of those 2 CPUs that have a speed of 400 megahertz as the number 1, and a different one as the number 2. And same with the 2 CPU chips that we have that are a 500 megahertz chip. Okay, and when we do that, we can identify all the different possibilities that we can draw. And so, for instance, we could draw up in that sort of top left corner, we could draw the first 400 megahertz processor as our x variable, and we could draw the second 400 megahertz processor as our y. Okay, what we can't do is redraw that first 400 megahertz processor twice, because remember, we're doing this drawing without replacement. So that means we do not put the processor back in the box, therefore it cannot be drawn again. And that's why we have a dash in that very upper left corner. And if we construct the outcomes of the experiment this way, then it's a reasonable belief that each outcome is equally likely, because all we're doing is randomly selecting each of these different chips. And so all of the x's in this table have equal probability. All the dashes have 0 probability because they both can't occur. All right. And now from this table, we can define the joint probability mass function. Remember that joint probability mass function here for these random variables x and y that we've defined are just the probability that x will be a certain speed and that y will be a certain speed. And so from this table, we can go ahead and we can figure out what those probabilities will be. So in particular, this is the table that summarizes that previous table, but now has the probabilities for these different events. That it has the joint probability mass function for x and y. And so to get this table, all you have to do is look at the previous table and say, all right, how many different ways are there to do this whole experiment? How many different outcomes are possible? And if you add up the number of x's, you get 20. So the denominator is always going to be 20. The next question is, for a particular event, how many different ways are there for that event to occur? So how many different ways are there to draw, say, a 400 megahertz processor followed by another 400 megahertz processor? Well, there's only two ways for that to occur, and those are the top two left x's, right? Either you can draw the first one first, or you can draw the second one first. Maybe I should say it this way. You can draw the number 1 first, or you can draw the number 2 first in terms of those two 400 megahertz processors. And so if you go through that process, you can find that, hey, the probability of drawing two 400 megahertz processors is 2 out of 20. If you look at the very middle cell, you can see that that cell has 0. This is the event that both x and y are 450 megahertz. But if you look at back at the table, right, there's no way for that to occur because there's only one 400 megahertz processor in our box. Okay, so this is the joint probability mass function for x and y. Now, using this joint probability mass function, we can answer a number of probability questions that we might ask. So for
Okay, so again, good afternoon. My name is Tarpin Makalib, but you can call me Thurs na lang. And I will be tackle the topic of the linear functions of random variables. And the first one is mean of a linear function of a random variable. The following rules express this more formally in words. The mean value of a constant a is a. And in formula, that is e of a equals a. If each value in a probability distribution is multiplied by a, the mean of the distribution will be multiplied by a factor of a. And in formula, that is e of ax equals a e of x. If a constant value b is added to or subtracted from each value in a probability distribution, the mean of the distribution will be increased or decreased by b. And in formula, that is e of ax plus b equals a e of x plus b, where a and b are constants. For example, by the way, in the first example, we will be using the first formula, which is the e of a equals a. And for example, the expected value of a probability distribution of the random variable x is 10. That is e of x equals 10. And the given is find e of 3x plus 4. We will be moving down the given, which is the e of 3x plus 4, and then ayun po, paghiwalayin po natin yung 3, ayan, para makuha natin yung substitute ng a of x. So,
Factor out.
ayun, factor out po. Thank you, sir. And then, ayun nga po, equals 3 e of x plus 4, and then substitute equals 3x plus 10. Kaya naging 10, it's because of the substitution, which is the e of x equals 10. So 3 times 10 plus 4 equals 34. Ayan. Next is the variance of a linear function of a random variable. The variance of a constant a is 0. And the formula, that is capital VAR, which is variance, in short, var, of a equals 0. If each value in a probability distribution is multiplied by a, the variance of the distribution will be multiplied by a factor of a squared. And the formula, variance of ax equals a squared variance x. If a constant value b is added to or subtracted from each value in a probability distribution, the variance of the distribution will be unchanged. And in formula, that is variance of ax plus b equals a squared variance of x. where A and B are constants. And for the example number 2, we will be using the formula number 2, which is the E of AX equals A E of X. Okay. For the second example, the expected value of a probability distribution of the random variable x is 10. That is, E of x equals 10. Given is, find E of 3x plus 4. Ayan, bababa lang. E of 3x plus 4 equals factor 3, E of x plus 4 equals, substitute natin sa EX, ayan, sa 10. Kung nakita nyo yung mouse, cursor, yan, nag-ano ko, nagpo-point, equals 3 times 10 plus 4 equals 34. Ayan, ganyan pa rin siya. Wait lang. Sorry sir, ito pala. Ayan. Sorry sir. Ayan, the variance of the probability distribution of the random variable x is 2 pala. So that is variance of x equals 2. The given is, find variance of 3x plus 4. Ayan, baba lang, variance 3x plus 4 equals 3 squared. Ayan, kaya kung mapapansin nyo, may squared kasi yung kaninang formula, ayan, may squared. Ayan, kaya ginamit natin yung second formula. Ayan, equals 3 squared variance of x. Tapos, okay, yan, substitution. Siyempre, i-compute mo na yung 3 squared. Ayan, hindi siya 3 times 2 kasi 3 squared nga. So, 3 times 3. Ayan, equals 9 times substitute of x equals 2. Equals, 9 times 2 equals 18. Ayan. For the third one, standard deviation of a linear function of a random variable, and the standard deviation value of a constant a is 0. And the formula that is SD, by the way, SD is the standard deviation. Pinaikli lang na SD. Ayan. SD of a equals 0. If each value in a probability distribution is multiplied by a, the standard deviation of the distribution will be multiplied by a factor of a. And the formula is SD for standard deviation of AX equals ASD of X. If a constant value B is added to or subtracted from which value in a probability distribution, the standard deviation of the distribution will be unchanged. And in formula, that is SD of AX plus B equals ASD of X, where A and B are constants. And for the last example, the standard deviation of a probability distribution of the random variable x is square root of 2. Ayan, so, may, square root of 2. And the given is, find standard deviation or SD of 3x plus 4. So, yan, bababa lang. SD of 3x plus 4 equals 3. Sabi ko kanina, factor out. And then SD of x. And substitute, it's equal to 3 times square root of 2. So, in total, that is equals 4.24. Ayun po, sir. Thank you po.
Hello. Good afternoon, sir. I am John Christian El Bautista, and I will be the one who will report for the last topic of Group 3, which is the general function of random variables. In this topic, there are basically three different techniques. First is the cumulative distribution function techniques, which was discussed in the last report. The advantage of the CDF technique is that it can be defined for any kind of random variable. It can be discrete, continuous, or mixed. Then univariate and multivariate distribution will be covered as well as discrete and continuous distribution. Then the next one is the transformation technique. This is the most general of the techniques, and just as was the case for the CDF technique, it also covers univariate and multivariate distribution, and within each of those, discrete and continuous distribution. Then finally, moment generation function technique. It is known as the this particular technique is used for sums and linear combination of mutually independent and identically distributed random variables. Compared to transformation technique, this method is restricted only for sums and linear combination. Next. Next, in this slide, we will talk about the univariant, bivariant, and the multivariate case. We know that the distribution of x, in univariant case, we know that the distribution of x and we want the distribution of y is equals to g of x. In the bivariant case, we know that the joint distribution of x1 and x2, and we want the distribution of y is equals to g of x of 1 and x of 2. In multivariant case, we know that the joint distribution of x1, x2 up to xn, and we want the distribution of y equals of g of x1 up to xn. There are three techniques for finding the distribution of y. First is the cumulative distribution function technique. Here, the CDF technique goes from the CDF of x to the CDF of y. Uh, the transformation technique goes for lowercase f of x to lowercase f of y. This technique is also known as probability density function, PDF technique, or probability mass function, PMF technique. The only difference is that if the random variable are discrete, then it will be called the PMF. If they're continuous, it will be called PDF. We all know that when the random variable is infinite, it is continuous. And if the random variable is definite lang, nabibilang lang siya, which it will be discrete. Then lastly, the moment generating function technique goes from the moment generating function of the individual observation to the moment generating function of their sums or linear combinations. Next. Function of random variables. Let the random variable x assume the values x of 1, x of 2 with corresponding probability of x of 1, then probability of x of 2. Then the expected value of the random variable is given by expectation of x, E of x is equals to summation of x of probability x. A new random variable y can be stated by using a real Borel. Ano babasa dito, sir? Borel. Measurable function g
Saan?
r sa Borel using a real
Yeah.
Borel po, sir.
Borel, measurable
Using a
function.
real Borel measurable function g r to r to the result of a real value random variable x. That is y is equals to f of x. The cumulative distribution function of y is then given by f of y is equals to g of x less than or equal to y. The transformation of a random variable means to reassign the value to another variable.
Saglit lang may
Transformation.
ano lang ako. Continue lang may check lang ako sa labas ha. Wait lang.
Continue daw.
Continue.
Oo, continue lang daw.
The transformation of a random variable means to reassign the value to another variables. The transformation is actually inserted to remap the number line from x to y, then the transformation function is y is equals to g of x. It only means that parang pinapalitan lang natin yung value ng y, tapos it equals to g of x. Next. If x is a random variable and y is equals to g of x, then y itself is a random variable. Thus, we can talk about its PMF, CDF, and expected value. First, note that the range of y can be written as Ry is equals to bracket g of x, which is x is element of Rx. If we already know the PMF of x, to find the PMF of y is equals to g of x, we can rewrite P of y is equals to probability of capital Y is equals to y. So, yung ingin ng capital Y. Then, tatransfer natin si y to g of x. So, probability of g of x is equals to y. Then, equals to summation of p of x. Probability of x of x. Next. Let's take a look at this example. Let x be a discrete random variable with p of x of k is equals to 1 pip for k is equals to negative 1, 0, 1, 2, 3. Then let y is equals to 2 absolute value of x. Find the range and PMF of y. First, note that the range of y is ry is equals to 2 absolute value of x where x is the element of Rx. Paano nakuha si Ry? Sa-substitute lang natin yung value ni k sa x. So, 2 times the absolute value of negative 1 is 2. 2 times absolute value of 0, 0 which is 2, ay 0. Nakuha na natin yung first. Yung 2 ito. Then, 1 substitute ulit sa x, 2 times the absolute value of x equals to 2. Na-notice natin na parehas siyang 2, so di na natin susulat yung dalawang 2, kahit isang 2 lang. Then 2 times the absolute value of 2, which is 4. Then 3 times the absolute value of 3. 2 times 3 is 6. So, nakuha natin yung Ry by substituting to absolute value of x. So, ang Ry is 0, 2, 4, 6. And to find P of y, we need to find P probability of y is equals to y. For y, yung nakuha natin kanina is equals to 0, 2, 4, 6. Then, isa-isayin natin sila. We have probability of 0 is equals to probability of y is equals to 0. Substitute probability 2 of absolute value of x equals to 0. Then probability of x is equals to 0 is equals to 1 pip. Probability of 2 naman. Then probability of y is equals to 2 is equals to probability of 2 absolute value of x equals to 2. Then dalawa siya, di ba? Yung negative 1 and 1. So probability of x equals to negative 1 or probability of x is equals to 1. P of x equals to x 1 is equals to 1 pip plus 1 pip is equals to 2 pip. Then sa 4 naman is probability of y is equals to 4 equals to 2 1 ulit. Then p probability of x equals to 2 plus probability of x equals to negative 2 is equals to 1 pip. Then plus what sa 6 naman, probability of p y is equals to 6 equals to probability of 2 of absolute value of x equals to 6. Probability of x equals to 3 plus probability of x equals to negative 3 is equals to 1 pip. Then, for 1 pip, for k is equals to 0.46. For 2 pip naman is k is equals to 2. For 0 naman is otherwise. To summarize, that's all. Let's take a look at this video for further understanding about the topic.
Hi, so we are going to try something a little bit different today. I've been making Camtasia videos for you, but we're into a bit of a harder section. Section 6.2 is functions of a random variable. We've now covered, I went through chapter 7, which we looked at some special random variables like the uniform, the exponential, the normal. And now that we know a little bit about continuous random variables in the language, one of the harder things we do with them is we take a random variable and we make a new random variable based on that original one. And often we just don't want, besides constructing it, we would like to know the density function of that new random variable. So that's what I mean by functions of random variable. If you have some random variable x, we're going to look at functions of that x, like x squared, or maybe square root of x, or ln of x, sine x. For some reason, maybe this is the length of a square and we're trying to find area. So there are reasons when you have a random variable that you're going to perform an operation on it and then want the distribution of that new random variable. So,
Ayan po. So, kung gusto nyo na lang pong panoorin siya ng full, may reference naman po. And PowerPoint. Ayan. Kasi, ano na po, overtime na. Sir, tapos na po kami.
Overtime na, no? Bigla naging time conscious, no? Ayun, so thank you, no? Thank you sa discussion for today, no? So I think, na-discuss naman nila yung pinaka category or yung mga types ng kada topics, no? So, yung iba naman kasi self-explanatory except for those calculation lang na may mga function ng real numbers. Pero the rest, yung pinaka concept ng joint probability, I think, or joint probability distribution is na cover naman nila. After joint probability, next na dito ay so we're done with the continuous joint. Then ang next na dito is yung sampling distribution and point estimation. So medyo ito yung medyo parang na-discuss natin na briefly nung nasa statistics tayo, yung sampling distribution. So it is more of a concept of estimation, no? So parang babalikan natin dito yung mga mean square, yung standard error, yung mga variance na diniscuss natin nung sa probability pa tayo. Pero more of ano lang to, more of sa point estimation na part. So pero hindi naman na tayo magko-compute ng mga mean, ayan, mga median. So more of error calculation and estimation. Then after that, I think last 2 topics, last 3 topics kasi last 3 abot pa tayo. Next week tapos so next week yung sampling tapos yung last topic natin will be November 3. So tama lang naman. So statistical interval, no? So yung mga types of statistical interval. Then after that that will be a final week na natin, no? So or finals week, no, para sa subject ko, no. So hindi ko alam kung ano yung schedule yata na final, which is 14 to 19 yata November. So mag-aahid lang tayo ng 1 week para syempre to give way dun sa pag-check ng mga papelanda, ng mga papers or to compute yung grades and mga quizzes nyo. Ano pa? Sorry pala kanina, medyo sabaw na ako. Kala ko ECE. Kasi yung ECE ko, 11 or 12 kami nagdi-discuss. Wala sa isip ko. Thursday pa lang ngayon. Question. So yung mga videos naman, I think share nila nila Makali dun sa sa PowerPoint nila. So you can copy that and paste na lang dun sa mga browser nyo to watch if you want you to get more interested dun sa mga topic. Question, may question kayo? Yung sabaw ko ngayong araw, aga ko kasi nagising. Na-stress. Nag-start na ako sa work. Questions. Hindi questions hindi related sa sa topic. Meron ba concerns? Kamusta kayo? Sino nga yun? Nasaan si Maui? Dito ba? Maui. Wala. Saan ba si Maui? Napunta na ba kayo school? Wala pa namang no? Ay, may nagtaas ng kamay. Sino yung nagtaas ng kamay? Sige. Question. Sige. Sino yung nag-raise a hand? Pumunta kasi ako. Nag-meeting kami kailan ba yun? Monday yata. So, after this term, medyo mahaba yung pahinga, no? Parang buong December. Tapos, ang resume na, tentatively pa lang to sinasabi ko lang sa inyo, pero internal lang sa atin. Based dun sa napag-meeting namin sa sets. So, para bumalik tayo sa semestral no? So, ayun ang na-announce sa amin. Kung aware kayo dun sa Unifas. So, one of the grounds dun sa Unifas is yung loading saka yung mga subjects. So, kaya baka bumalik tayo ng semestral. So, 2 sems na tayo imbis na na trisem. So, kung babalik ng 2 sems, so most probably sa January na yung next sem natin. So, hopefully, no, hindi ko alam kung I will be still part of the CMU roster, pero pinag-iisipan ko pa kung magpapa-renew pa ako nung teaching load. Alam niyo naman medyo magulo sa CMU. So, ayun. So, babaguhin yung mga loading nyo, so malamang babaguhin yung curriculum or depende. May titingnan nyo kung yung curriculum nyo na hawak or ang tawag yata sa inyo is prospectus is aligned, no? So, hindi ko alam kung mababawasan yung mga subjects or madadagdagan. Pero mostly, tatanggalin na yung mga subjects na hindi na related sa computer engineering. Then, sabi, that will be yung next term yung next sem natin will be a full face-to-face. Pero hindi ko alam kung anong klaseng notation ng face-to-face, kung pwedeng hybrid or meaning pag sinabing hybrid yung kumbaga kung may laboratory lang saka lang pupunta na school. Then yung lecture pwede namang gawing online. Hindi yung katulad dati na syempre na every meeting kahit lecture is nasa school tayo. Depende rin yun sa capacity. So, ayun yung na-announce sa amin. So, wala namang major pa na changes. So, status ko lang kayo, ayun lang, in the next term or next sem, medyo yung mga ina-expect yung subjects siguro, kung may ina-expect na kayong mga subjects, baka mabago pa. So, siguro isa-send nila yung panibagong curriculum for semestral. I think kasi yung copy nyo is nasa trimestral yung mga subjects. So, i-check nyo, no? Kung ibasa nyo kung may mga kulang. So, i-try nyo, i-take, no? Kung may offer na, no? So, by January. So, hindi natin alam kung anong magiging final verdict. Malalaman natin yan siguro sa mga susunod na araw. Ano pa? Bago na yung din natin. Sir, uniform po ba binago? Wala pa yung uniform. Feeling ko naman siguro wala pang sinabi about uniform. Kasi list priority naman nila yung uniform. Kasi yung uniform madali lang naman i-produce yan. So, pero kung hybrid, siguro once a week lang naman ang punta nun sa school or twice. Siguro baka feeling ko pwede naman na civilian. Pero wala nga nasabi about uniform pa eh. Ano pa? Ilan nga kayo? Meron na bang may mga hindi ba pumapasok na? Hindi ko na masyadong na-monitor eh. Carmela, wala yata si Carmela eh. Ilan na kayo final?
57 po ata, sir.
Wala, ano yun, intact na yung 57.
Apo.
Walang
Yung nabawas lang naman po sa 58 si Jolo lang po.
Jolo, sino yun? Natanggal ko na ba yun?
Apo.
Okay. 58. Sabihan niyo ako pag kung may kunyari may nagsabi yung magda-drop pala, baka hindi ako aware. Tapos hanapin ko ng hanapin. So, kailangan kasi ma-finalize na natin yung record nyo. Bago mag-finals, para alam natin kung sino yung mga magpa-finals sa hindi. So, nasabi ko naman yung reporting nyo, that will be your long exam or yung pinaka-presentation. So, ang katapat na grade nun kasi is parang nasa yung midterm. So, kung mababa kayo ng midterm, maganda yung reporting nyo. So, mahahatak naman yun. So, then, let's check na lang kung may final exam pa. So, depende. Kung kailangan ng hatakan ng iba yung mga grades or may mga bababang grades, magbibigay tayo ng final exam. Pero kung lahat naman is okay, so, kahit hindi na tayo mag-final exam. So, pero that will be announced naman. So, depende pa sa magiging status natin. Ayun na lang. Siguro isang quiz na lang din, major exam. So, para hindi na masyadong mabigat sa inyo. Ayun. Yun na lang yung magiging natin, basis. Attendance, hindi naman ako masyadong mahigpit. Alam niyo naman yun. So, kahit yung iba is pasulpot-sulpot or pawala-wala. Pero okay lang naman. Okay. Concern pa. Ayun. So, may concern pa kayo? Sige, paki-on na lang ng camera. Konting lang tayo. Stop recording ko na para mag-save na siya. Charge gallery. Hintayin lang natin mag-load. Yun, no? Umulan pala. Hindi ko napansin. Yun. So, tunay ba yun? Marami pa. Hintayin natin iba mag-load. Yun, no? Ang iba parang inaantok pa. Si Vasquez naka-condenser Condenser ba yan tawag? Okay, sige, game. 1, 2, 3. May mahabol pa, hindi lang. 1, 2, 3, go. Doon ko na lang pepe sa group. Isa pa. 1, 2, 3. Yun, may mahabol pa isa. Si Cyrus. So, yun. So, kung wala na question guys, no? So, thank you, no? So, humaya kayo at magpakarami.
Thank you po, sir.
Thank you,
Thank you po,
sir.
sir.
Sige, sige.
Thank you po.
Thank you, sir.
Thank you, sir.
Thank you po.
Replied. Focus lang, sir.
Thank you po.
Sige, sige, sige.